So what's the thing you want me to look at? You said there's
the new iPhone bug that's caused by apparently like a date setting in Unix. Where if you don't set your phone to it, don't set your phone to January 1st, 1970.
You can change the date.
Yeah. It will slaughter your phone. You will have to get a new phone.
Slaughter your phone.
Yeah. You literally have to get a new phone.
How do you interpret this? So a lady texts me from our church who claims she left booze for us on a table at the church.
Say yes, ma'am.
She wants me to make sure I bring a corkscrew. She's not going to be there. Just bring the tools you need to get into the alcohol.
Tell her good. We'll leave the money at the drop site.
All right. So let's read the thing you sent me. Okay. So
yeah, that was just like an excerpt on it.
The bug appears to only affect 64-bit iOS devices, meaning... All right, so you're saying there's some iOS...
Yeah.
iOS...
Yeah, set your phone to January 1st, 1970, and yeah, you'll find out.
Is it the...
I wouldn't advise you.
So iOS bug?
For science, is this the...
There's the iOS date trick, this guy?
Yeah, that one.
All right.
Yeah, I wouldn't call it a
This
trick.
one said trick. What's the trick?
Hey, fair, man. You gotta check out this new little trick they found. It's an Easter egg in iOS. Set your phone to January 1st, 1970.
No, don't. All right. So setting the date to January 1st, 1970 will brick your iPhone, iPad, or iPod Touch. Date bug will prevent 64-bit iOS devices from booting up, rendering them inoperable, even through fail-safe restore methods using iTunes. So it's like done?
Oh yeah, you have to get a whole new phone or take it.
through iTunes. I bet you can use.
Manually setting the date in your iPhone or iPad to January 1st, 1970, or tricking your friends into doing it will cause it to get permanently stuck while trying to boot back up if it's switched off. The bug within Apple's date and time settings within iOS causes such an issue that users are reporting that the fail-safe restore techniques, blah, blah, blah. The precise cause of the issue has not been confirmed, although speculation points to the way iOS stores date and time formats, meaning that January 1st, 1970 is stored as the value of 0 or less than 0, causing every other process that requires the timestamp to fail. So the idea is that a lot of, in POSIX operating systems, there is a time since 1970 long. It's a long integer that tells us the number of, I think it's a number of milliseconds. I think it's a number of milliseconds. Huh?
What's text? It's text.
I don't think so.
Yeah.
Well, you might be right, but that's not how I've ever heard it. Yeah, I think it's number of milliseconds since 1970, which is roughly the start date of Unix, which I think we mentioned that at some point in the slides here. So the idea would be, assuming this is correct, that the difference between today and if you set the date to January 1st, 1970, it's seconds since 1970? Okay, so if you set the date to January 1st, 1970, chances are it's going to end up being a value of a negative value for the difference between right now to when the current date on your phone is. So when it tries to boot up and it tries to set the date time, it gets a negative value or something like that, which causes the world to end. And I think this is all part of that Kanye album. What's up?
The world ends on Sunday.
Right. Is that it? Is that the new world end? Yeah. Is that the same 2012 guy who keeps amending it?
No, it's not. Ghostbusters 2?
Yeah. No,
oh, that's right.
2012 was mine.
Right. But wasn't there some guy a couple years ago?
Harold Camping, I think.
Yeah, then he updated it. He said the math was wrong. They did a...
Updated it like 10 times.
Yeah.
Sure.
He's dead now.
Oh, yeah. Is he?
What happened to him?
So
I'm sure somebody will take his place.
He was correct. His world ended.
It was a divide by 4 carry bit problem.
Off by one.
The book of Exodus doesn't make sense otherwise. All right, so I'm guessing
Yeah.
that's what happened. What's happened? It's probably, which is funny because it likely is something that is just integer math that's causing an operating system not to get past a certain point. But now the real question is why can't it be restored? Because even if it's at the firmware level,
You just have to take out the battery so it forgets the date.
No, because it automatically sets it back to 1970. I just read the article and they said that in there.
Even
so.
if
yeah, well, he read it on Kanye's blog.
Yeah.
I feel like this would rather be something like B.O.B. set up, with the flat Earth thing that he's been rambling about lately too.
Would your watch get there?
Try setting the watch to it. It ends up bricking the phone because the watch is reliant on the phone. I bricked my iPhone from across the room.
Just grab somebody's watch. Hey, can I see
Well,
that?
if you
real
want to
quick?
fall, that's a pretty good way of getting one.
All right, so let's.
Get a cracked screen.
I started to-
Yeah, that's smart.
Okay, so how did the homework go? Everybody got Cloud 9 and got the stuff typed in and compiled and all that jazz.
To the error point.
Okay. All right, so let's. Did I? I doubt it. Did I?
No.
No.
Yeah, you just got serious.
Should I? So what happens? So you got to show me how to do that. So I got to go to this.
Yep.
Open, and then this is the link.
Updated 20 minutes ago?
Boom.
What'd you do?
My charger for my phone doesn't. Charger for my laptop has gone kaput. So my laptop just drained to its death. And so I was borrowing Professor Wall's. All right, so this is the link I have to give you.
Sure.
So that's
Oh, let's go for it. See what happens.
Yes.
The worst that can happen is we have access to your code.
well, this is just gold code. I mean,
Yeah, it's brilliant.
it's built in.
You wrote it all.
I have pretty. I'm actually feeling pretty confident that we're going to omit the books code and just go back to no error checking or write our own error checking libraries. But we'll see how far the rabbit hole goes. Do we?
So what was your charger?
I think so. Yeah. I ordered another one off Amazon. Like a real Apple 85 watt charger is like $78 or something like that.
$80, yeah.
Okay. I got one from Panama for like $17.
That's scary. Is your laptop gonna explode?
It's from Amazon Prime, so if it doesn't work, I always send it back.
Yeah, but
I
it
was-
doesn't work
it might-
on a laptop.
Well, I'd say it might work, but it might.
My only has to
explode your
last me like
battery.
another month.
Why? What happens in the
Well, that's probably when Apple announces their new laptops.
Wait, you can announce it.
Well, whenever it comes out, I'll order it, and then it comes in, and then I'll start using this one as a bath mat. What's up?
September's when they the cycle they're on for releasing stuff.
I think Mac Pros are pretty far behind. I think the last
It was
Retina was a
barely-
March
yeah.
release.
In the last update, so it was just like slight.
Yeah, so I don't know if you're getting this on Slack anytime soon. Here, should we go to Res Hall?
I'm on Eden. Oh no, I'm actually on. No, that's weird.
They're all
I
terrible
was on
today.
Eden.
What's the link? We can just type it out.
No, you can't.
No, we can't. Does it work that way?
ID c9.io/mlitman/CSC450.
Just do c9.io /mlitman.
Ah, we're in.
That time it said we like you.
Did it?
Yeah.
There. Okay. So let's. All right. So we got to look at these errors we were getting. undefined reference to usage error, error exit,
Baseball, Widespread. Widespread 220 came on.
So it's this guy? Fix this code anyways, make it look better. So usage error. So is this like other people touching my code? Can you actually change text too? Oh, but you could like highlight it and stuff?
Yeah.
That's gonna get annoying. We're gonna have a lot of quizzes.
There's got to be like a view, like under view, probably options to get rid of it so that you can't see it.
Why do we have something in here called the gutter?
It's probably under share on the right.
Yeah, that's goat boil, right?
Editor. Who has access? So this one? Are you sure you want to make this change? Only users with read-only or read-write access will be able to access the workspace. Well, I want you guys to be able to see it, but not really be able to highlight stuff and have it show up on my screen. So these are all the people currently using it?
Yeah.
Yeah, we still highlight.
Yeah, you just gotta kick Nick out.
Is it Nick doing it? You're highlighting?
Yeah, you can.
I just.
Well, stop.
You can just go over and see who it is.
Stop highlighting.
Yeah, look, my face just appeared.
Broken now.
All right, so let's look at these errors. So we have error exit. And where is that guy? So undefined reference to usage error, that's this guy right here, which should be in, here's our error functions. And here's usage error, here's error exit as well. So this is in error functions.h, which isn't that in our TL blah blah? Error functions.h. Oh, actually, do we have to? I bet you we need to do this. Same thing with the getNum.h. These are in the local library. Because aren't we currently running this inside of the lib directory? That's what we did? All right. And is the TLPI HDR in there? It is TLPI HDR. Okay, then I assume that there is an error function.o.
Where you can chat that too.
There's like a collaborators tab.
Go Kanye at 99 cents. Alright, so this is error functions.c, which includes error functions.h as well as this guy. So does that kind of create an infinite loop? Because we're including TLPIHDR, which includes error functions.h, which includes TLPIHDR, which includes error functions.h. Which...
Vicious circles.
That's just dumb. All right, what else is this guy using? Here's our TL. So everything is a standard library except this getNum and the error functions, right? It is error underscore functions dot C. I'm going to try something here. I'm going to take it out of there. We'll save this. I'm going to put it in.
README would help you out at all.
What's up?
Read the README.
What does it say? Okay. Is it, you mean the README on here?
Yeah, it's in the lib folder.
Okay. Handle errors for system calls and C errors. Well, that doesn't tell us anything about the why it's not working. It just says that the thing that's not working might not be useful anyways. All right, we're going back. All right, do I still have it in there, or did I? Is this my original copy? See?
I think that's the one that you took out all the error checking.
Yeah, good. And this is the original one of these that does not have getNum, right? Get rid of getNum. Alright, so let me get all these closed here. This would be better anyways, that way we don't have to deal with this giant thing of library calls. Alright, so we're gonna do CD, GCC copy.c, that should work, okay. And we'll say ./a.out, copy.c to copy Kanye.cp. KK thanks. All right. Can I make that any bigger down there? This is like a settings. Oh, here, settings. Font size. That's font size up there. Is there a font size down here? Who knows? Whatever. Okay. So, and here's our decopy. So cat decopy, and there's the file. All right. So this handles everything but error checking, which is fine. So I think this is what we want to work off of. That way we don't have to deal with this dist thing. We'll leave it in here in case we need to get at any of those libraries for anything else from the book, but we don't error check anyways. We want to focus on this other stuff. And we could always write our own error checking, but we probably won't. All right, so let's look at some of these commands for when we are opening files. So as we saw last time, right here is where we're opening a file, and we're giving it some flags. All right, so when we open this file, we're giving it as an open read-only, and then we're also setting some open flags that we're going to use for our output file that we're opening. This is our input file that we're opening, so we're going to just open that one as read-only. It's these open flags that become a little bit weirder. Remember, these are the bitwise ORs. This is going to create a mask between these three values. These are integer values that we're bitwise ORing together. But let's look at what each of these guys mean. So here in the book we have our normal flags: read-only, write-only, and read-write. So this is what we want to do with our with the file. So if we're reading a file in for read-only, you're safest to open it for read-only. The operating system will put it in a different mode. If we're writing it only, it'll also be different. If you need to do read and writing, it's going to put it under a different subsystem in the operating system to handle file locking, because we might have more than one person writing to that file at the same time. Okay, so set the close on exec flag. So this must be if somebody tries to execute this file, then the file will actually close out of memory. And by execute, we mean run the program. Here's the create the file if it doesn't already exist. And I think we did that for our output, didn't we? Yeah, output flag is create and write only. direct file IO bypass buffer cache. All right, so this must write directly to system memory rather than through a cache that then goes into memory. So this should fail if the path name is not a directory, so only open if it's a directory. Create file exclusively. So I'm guessing that guy automatically creates a new file regardless of whether it already existed. Well, it says with create, so it's probably create bitwise ordered with exclusive. That would be my guess. Large file, it's going to have performance benefits for opening large files that we're going to be reading stuff in, because only part of it's going to get loaded into memory. If you remember from the operating systems class, we talked about paging, where files get broken up into individual pages, and then we have frames in memory, and not necessarily all of a file is loaded into memory at once. So we have swap space that swaps things in and out of memory as needed. So if we try to write to page 4 of a document, and page 4 isn't currently in memory, it'll swap it into memory. That's going to be an interrupt to the operating system. Let's see, don't update file last access time on read. So if you are reading from a file, every file has like a bunch of different timestamps. One of them is when it was last accessed. So they're saying don't update it on just a read. So last access will be whenever somebody changed the file. Last time it was written to, not when it was read. Don't let path name become the controlling terminal. Okay, so the idea for this one is when we have a file running, when we have, like, for instance, I assume I can do it out here at Cloud9. I'm just going to say top. So now I'm down here running the top command, and it has controlled my terminal. So that file top, when it was opened, when it opened into the file descriptors for this, if any of them were set that they couldn't become part of the controlling terminal, they wouldn't be able to take over the terminal like this. So because this guy has taken over the terminal, at the very least the top file name is allowed to take over the terminal. Otherwise, there are some things that might just, they're files that maybe aren't meant to be executed. Maybe they're files that are just data files. And if a file's not meant to be executed, we probably don't want to let it take over the terminal anyways. But maybe you just wouldn't because you would never execute it. Maybe you don't need this command line thing. Symbolic links, we haven't talked about them yet, but think of these as like pointers to other files. Maybe we did talk about them a little bit, or at least mention them. Okay, but don't dereference those guys, so don't follow any symbolic links that are in this file. This is the thing we saw last time, truncate existing file to 0 length. So if you open a file and it was already created, but you want to effectively start a brand new file, you would use the otrunc to start with a blank file. As opposed to oappend, where writes are appended to the end of the existing file. I suppose otrunc and oappend working together would be contradictory, right? It's like, we're going to wipe the file out and then always just add to the end. Which means you're also adding to the beginning of the empty file. So you probably wouldn't use those guys together, but it probably would allow it. Async, generate a signal when I/O is possible. All right, so this is something that would have to do with file locking. So we've talked about asynchronous communication in some other classes where if we have a file that's been opened, whether it's read or write, all right, and we might have multiple processes writing to this file. What we can now do is we can have this file create a signal, which is an operating system inter-process communication tool, whenever that file is available for writing. And then one of these dudes, one of the 5 processes that is listening for that signal, will grab the file and start doing I/O with it. Phrasing?
We'll allow it.
I'll allow it. So we'll start doing I/O with the file, which will then mean nobody else can access it at the same time. So this is asynchronous communication built into the files. Provide synchronized I/O data integrity. So this probably forces with file locking that only one person can access the file at a time. So rather than you having to create scenarios where different processes become aware when a file is available or not available, this guy just says, hey, you can write to it whenever you want to try to write to it, but we're going to lock you out until you're allowed to write. Which then means that we're breaking that idea of the observer design pattern, right? Because if I'm a process that wants to write to this file that's set up for to be synchronized, I'm going to start trying to write to that file. It's going to block me, and I'm just sitting here waiting for him to become available. Could be 5 seconds, could be 5 minutes, could be 5 days. Make sense? So this would be pretty inefficient if we were synchronously writing to files and one file blocked a process from writing to it indefinitely. Okay, open in non-blocking mode. So that would actually be kind of interesting if you did this with the desync, because those things would contradict each other. So non-blocking mode says anybody can do anything to this file you want but deal with consequences. But all file lock stuff should be turned off. make file writes synchronous. So this is similar to synchronous versus, well, similar to asynchronous communication, where asynchronous communication gives us, well, let's look at it this way. Synchronously controlling the file itself means only one process can access the file at once. Synchronously controlling the writes to a file means only one process can write to a file at once. So when one process finishes writing and then goes back and does some more logic, maybe to read in more bytes that it might want to write in a second, another process could sneak in and write something to the file. Okay, because it's only synchronized on an individual write, not across access to the file. Make sense? So we have a lot of different granular ways that we can deal with files opening. Okay, so that kind of explains a bunch of that stuff. We decided that errors are dead to us. Well, these are actually errors that can, if you look at the open command here, well, actually, is the error going to come from? Will it be returned as the file descriptor? I think it will be. All right, so these are various errors we can get from trying to open something. Maybe we don't have access to it. Maybe we're trying to open a file that's actually a directory, so that's not really we're not allowed to do that. Directories are their own data structure. They look like files, but they actually are something else. So it'd be similar if we try to open a USB. Well, USB would probably be a bad example. Be similar to like open the maybe you have one of those USB things for scanning QR codes. So open that for writing. It doesn't make sense. It's a device and it inputs, not outputs. So it's not a thing. So this is an error dealing with resource limits on a process. How many maximum file descriptors, something like that. Number of open files has been reached. File doesn't exist. File is read-only and we tried to open it for writing. File is executable and it's currently being executed, so we're not allowed to modify it. Although, tell me, based on your knowledge from the operating systems course, would it be a problem if we modified a file that was currently executing?
Copy of it in RAM and active memory.
Okay, so when we execute a file, what's actually happening?
We're copying that file onto RAM.
Okay. What is the nature of executing a file in Unix? What are the different kinds of files we can execute? We talked about this when we were going through shells, and we've talked about this with C and C++. When we compile a program, a C program, what does it turn into? Binary. That's effectively, a low-level language. Effectively will be zeros and ones talking to the CPU. It's a separate file, right? So we've compiled copy.c into, I keep calling it a.out because that's the default output, and there is a way to decide you want to call it copy or something. So if I were to change a whole bunch of stuff in copy.c, maybe go in there and erase all the code and replace it with like My Little Pony fan fiction. Would the C file still run? The a.out, that would still run because that hasn't changed. That was already compiled.
What made you think of that?
What?
My Little Pony.
You don't read My Little Pony fan fiction? What's wrong with you? What kind of CS major are you? There's two kinds of CS majors. Those who see Deadpool and those who read My Little Pony fan fiction. It's one or the other. Okay, I think we all know which one I am. All right. Oh, I also am an expert jungler. With what's the green guy's? Zach. I use Zach.
I don't think anybody's used him in jungle since.
That's why they don't see it coming.
Wow. This is a thing. My
What?
Little Pony fan fiction is a thing.
It exists, there's fan
But did I indicate that it wasn't a thing?
I didn't think it was an actual thing.
Of course it is.
Not surprised.
There's fan fiction of everything.
You should see some of the mashups they do with the Marvel comics.
If it exists, there's fan fiction of it. The two overlap too.
All right. Let's see. So here is a.
It's mostly in Spanish.
Shut up. Okay, so here's the create system call. So we can accomplish creating a file using the open call with the ocreate flag, or we can just create a file from nothing if we know it doesn't exist, or we want to try to create a file, and we'll get a -1 if it's an error. So if we try to create a file that already exists, we'll get a -1. Think about this from a problem-solving perspective, similar to some of the things we've done with index of in Java, where we can, let's say we want to, before we check to see if a file exists, maybe we try to create it. If we get a -1, that must mean it's already there. So we could just go ahead and open it. That makes sense? That might be helpful for us to find out if a file exists, by trying to create the file and then looking at the return type. What if it does exist? Or what if it didn't exist, therefore we actually created and got a file descriptor? We got a real file descriptor, then we know that it didn't previously exist, but it exists now because we built it. Then we'd have to go and destroy it unless we wanted it to exist, right? So got to think about the consequences of those IO calls. All right, we've seen this read stuff. We've been using it, blah, blah, blah. Writing to a file, we've been using it. Close. Closing a file ultimately takes it out of memory and saves it. Okay, so file offsets. We have this thing called lseek. So for each open file, the kernel records a file offset. Sometimes it's also called the read-write offset or pointer. This shows us where in the file we are currently sitting. Now, initially, let's think about this from a single process's perspective. Okay, single process's perspective. We have one open file and only one guy reading that file, as opposed to if we have 30 different processes reading that file. So one guy reading this file, and we have this read-write offset or pointer. So it's the location of the file where the next read or write will commence. So if we've done append, the next write will always be the end of the file. But if we're reading, and we're reading in 1 byte at a time, or we've been reading stuff into this buffer, so maybe we're reading stuff in 1,024 bytes at a time, well, the next read is going to be, let's say read number 2 will be 1,024 at byte 1,024, because we've already read in byte 0 to 1,023. All right, how does that translate if we have multiple files reading it? If I've opened a file for reading, and then Tim opens a file for reading, is that the same file? Or do we each have a copy of that file open in memory at the same time? Yeah, we each have our own copy. So we would each have our own read-write pointer, correct? Now when I write to the file, and Tim writes to the file, are we writing to the same file or our own copies of the file? Okay, when would it end up being the same copy of the file? Okay, and what actually saves it to disk? Yeah, so this doesn't really happen to us anymore, but if you think back historically with like Microsoft Word, you'd be working on a term paper or something, and if you didn't save, and all of a sudden there was a power outage, you've lost your whole file, right? Even though you were writing to that file multiple times. Because not until you actually hit save until you actually hit save, did that file get written to disk. So any changes that we make, whenever we write something, those changes are made in memory only. Okay? And when we actually close the file, that's when the changes should become permanent. So let's actually explore this a little bit. So we're going to go into our code here.
So is hitting the save button considered closing the file then?
Yeah, I want to think how Word does it. I think, and that it'll be interesting to see what happens here. Modern operating systems do have kind of a middleman in there, and they might have an autosave. I don't think Linux does, so I think this should work the way I expect it to work here. But historically, what would happen is you would actually close the file, then immediately reopen it and seek to the same place you just were. That effectively did the save. But I think there's shortcuts to that now, where it doesn't actually require the file to close. You're instead giving it a write to disk directive, which is different than a closing directive. All right, so in this particular example here, we have a file that we're writing out. So here's our input file. This is one we're reading in. Here's our output file, the one we're writing out. Here's where we are writing out to these things. So let's look. Oh, I may have actually lied to you. All right. So we're opening it. As long as we can read stuff from the input, we're going to write it to the output, and we never actually close it. So it is self-saving. This is actually fairly poorly written code, because we should specifically close the file when we're done. We should use the close system call and pass it the input FD. Not that important to close an input one, but at least we're giving back the file descriptor. And that's a lowercase d. And then we should close output FD. And that's what should actually trigger the save. That again, more to copy. So there's all this stuff in there, but it was there even when I didn't close it. So that's telling us that this operating system does autosave from memory, possibly at various increments. So we might not necessarily know how fast it happens. If we go in here and we, let's see, it would probably write it, it would close it or save at some point. All right, so that becomes a weird operating system decision. Because on one hand, historically, a file does not actually get written to disk until we close it, from a system call perspective. Therefore, if I was writing a bunch of stuff to a file, and Tim was writing a bunch of stuff to the file, and neither of us ever closed the file, maybe our program just ended without closing, that file actually hasn't changed. Our own little memory locations for the file had a bunch of stuff written to it, but that never actually made it to disk. Well, now it's automatically making it to disk. So whose file makes it to disk? This becomes kind of an interesting situation. If more than one of us is writing to the same file independently, so if Tim and I both open the same file, we're writing to it. Depending on how the operating system handles the writing back to disk, it could be that this file ends up becoming like this mixture of, of both of our files, because I might, it might write my version of it first.
So like when two people push to GitHub at the exact same time?
Well, but it should be at least marking those on GitHub as two separate things. So, okay. In any case, it looks like close isn't necessarily required. That might be a Linux only thing, but regardless. So for your homework, and I'll post this code up as a starting point. Rewrite this program to display the new file in reverse. So we're going to read in a file, and we're writing out to a new file. But we want that file to be upside down. The last line in the new file should be the first line in the
By line or by character?
by line. Well, same thing. Character. Yeah, it should be upside down. So you could think of a line as a 1024-bit chunk. Make sense? So there's a couple different ways you can approach this. You can approach this from an array perspective. You also might choose to approach this from a flag perspective, how you write to a file. Make sense? All right, so look at those system calls, and I will see everybody on Monday.